Let's take a look at our last example here where we're converting within one of the measurement systems. Problem 8 says the order reads cimetidine 400 milligrams PO BID. Well, now we know what PO stands for, by mouth. This means the patient is to receive 400 milligrams of the drug by mouth twice a day. That's what BID, in a prescription, that's what BID stands for, twice a day. Part A says, the label on the bottle of cimetidine states that each caplet contains 200 milligrams. How many caplets will the patient be given for each dose? So the dose is that the patient is to receive 400 milligrams of the drug. And we're giving it to the patient in the form of a caplet. So we want to know how many caplets should the patient receive. Well, if you look at your equivalence charts, there's nothing there about milligrams and caplets. That's the information that has to come from the label on the drug. And in this instance, it said that according to the label on the bottle of cimetidine, each caplet contains 200 milligrams. So one caplet contains 200 milligrams of the drug. So we can use this relationship to get from milligrams to caplets. We want milligrams to go away. We want caplets to remain. So my dimensions in my conversion fraction need to be set up that way, so that the milligrams will be able to cancel. We'll be left with caplets. One caplet contains 200 milligrams of the drug. 200 goes into 400 2 times. We would give the patient 2 caplets to make sure that they got the 400 milligrams of the cimetidine. So here's an instance where the form of the drug was, in this case, a caplet. And we had to go from the amount of drug the patient was to receive to the correct form. And the equivalence, the relationship, was defined for us by the label on the bottle. Well, drugs are oftentimes not just given in solid form, a capsule or a caplet or a tablet. They can also be given in liquid form, where the drug has been dissolved in some sort of solvent, some sort of diluent. Maybe it's just water. And we need to measure out the correct amount of that liquid so that when the patient drinks that liquid, they're getting the correct amount of the drug. So let's look at Part B. Part B says, what if the cimetidine comes in a liquid form? The label on the bottle states that each 5 milliliters of the liquid, okay, so each 5 milliliters of the liquid contains 80 milligrams of the drug. How many milliliters should you administer so the patient receives the prescribed dosage? Well, again, the patient is still supposed to receive 400 milligrams of the drug. But now we're not giving it to them in the form of a caplet or a tablet or a capsule. We're giving it to them in a liquid, so we want to know how many milliliters of that liquid should we administer to them so that they will be getting the 400 milligrams of the drug dissolved in that liquid. This relationship can get us from the solid to the liquid. Milligrams is a measurement of solid drug. Milliliters is a measurement of a liquid. So the patient is to get 400 milligrams of the solid drug, but we're giving it to them in a liquid, so this is what we're going to use for our conversion fraction. We want milligrams to go away. We want milliliters to remain. And from the bottle, 5 milliliters contain 80 milligrams of the pure drug. So now we can arrive at the dimension we want, milliliters. We do the arithmetic. Well, let's see. The numbers were chosen nicely here. 80 goes into 400 5 times, doesn't it? And what's left? 5 times 5 is 25. So if the cimetidine was coming in a liquid form, we would want to give the patient 25 milliliters of that liquid to make sure they were going to receive the 400 milligrams of the drug. So here are some examples of conversions. And notice we've always stayed within the same measurement system. It was either in the metric system or in the household system. The next set of conversions we look at will cause us to move between systems on occasions. And the process is the same, we just have to use a different set of equivalences to help us.